Okay, we're going to do some graphs just on plain paper to help you organize your paper. You're going to fold it in half, hot melt style. Then I'm going to do it sideways, and this is going to give me 6 graphs. So I'm going to actually cut it down into thirds. So I'm going to do one graph here, and then another graph here. So that gives me 6 sections. And the first graph I want to do is an exponential. And it's y equals
e to the x. Now if I have an xy axis, I want to plot this graph. And here's what it looks like. Because there's a hidden 1 in front of that e, this graph goes through 0, 1. And then it starts really low along the x-axis, never goes below it, and creeps up, and then starts to grow really rapidly or exponentially. And there's only one really nice coordinate on this graph, and that coordinate is 0, 1. People in college algebra, they're asked what the domain and range is. So the domain for this graph is negative infinity to infinity, and the range for this graph, it starts at 0, but it never really touches 0. So it's going to be parentheses 0, comma, and then it goes up forever to positive infinity. Graph number 2. Is going to be y equals 2 e to the x. So I'm going to do my xy axis. Now instead of going through 0, 1, because it has a 2 here, it's going to go through 0, 2. Again, it's going to creep along the x-axis and shoot for that point. Once it goes to that point, it's going to increase rapidly. Domain and range for this one are the same. It just goes through the y-axis at a different spot. So the domain is going to be negative infinity to infinity. The range is going to be from 0 to infinity. My third graph is going to be a phase shift. Y equals e to the x minus 1. So I'm going to do my xy axis. There's a hidden 1 in front. Now the original graph was supposed to go through 0, 1. But because I have this minus 1 here, it's now going to shift everything down, even this horizontal asymptote. So now I'm going to have a horizontal asymptote instead of at 0 at y equals negative 1. And instead of going through 0, 1, it's actually going to go through 0, 0. And then my graph is going to grow rapidly once again. It's going to creep along the line y equals negative 1. Go through that point and then grow rapidly. The domain for this is going to be negative infinity to infinity. So it's starting to get redundant. So the domain is going to be negative infinity to positive infinity. The range, however, is going to start at y equals negative 1. It's going to start at negative 1, but it never touches negative 1. It just gets really close to it. And then goes up to positive infinity. So as you're following along, notice the format. So I'm going to do 3 more graphs. Number 4, number 5, number 6. I'm going to put my xy axis, my xy axis, my xy axis. Graph number 4, the equation is going to be a little more complicated. It's going to be y equals e to the x minus 1. Notice, the minus 1 is in the exponent, whereas over here, the minus 1 was outside of the exponent. So this is going to be a phase shift, not going left. It's going to go right 1 unit. So my original graph was supposed to go through 0, 1, creep up along the x-axis, and go through that coordinate, and then grow rapidly. This whole picture is going to be shifted right 1. So that spot is going to go right 1. And the go-through coordinate is now going to be 1, 1. The graph is going to creep along the x-axis, never go below it, and then grow rapidly. The domain and range for that. The domain is going to be negative infinity to positive infinity. The range is going to be from y equals 0, the lowest y value is close to 0 but not really at 0, to positive infinity. The next graph. Y equals e to the x plus 1 minus 2. So for this, I'm going to implement our old friend, opposite same. Some people think that this is easier to graph because it gives you more to grab onto. It's like climbing a rock wall. The more rocks on it, the better off you are. So opposite same. So that's going to be negative 1, negative 2. So what I'm going to do is I'm going to take the coordinate 0, 0 and move it left 1, down 2. And that's going to be my new starting point, my new XY axis. And notice there's a 1 hidden up front. So from there, I went left 1, down 2. So my go through is going to be at this coordinate here. My graph is going to creep along y equals negative 2, go through that coordinate, and then shoot upwards. This spot is negative 1, negative 1. The domain is negative infinity to positive infinity. The range is going to be now from y equals negative 2. So negative 2 to positive infinity. Number 6. Y equals 2 e to the x plus 1 minus 2 outside. Again, I'm going to implement the opposite same. So that's going to give me, opposite same, that's going to give me negative 1, negative 2. All this is this graph, number 2, y equals 2 to the x, 2e to the x. Everything shifted left 1, down 2. Left 1, down 2. It's just a phase shift of that graph from number 2. So I'm going to take a look at it. I'm going to use this as my 0, 0, and I'm going to move my 0, 0, left 1, down 2. And that's going to be my new origin, where I'm going to graph this function. Notice it has a 2 up front. So now it would go through, instead of 0, 0, 0, 1, it would go through 0, 2. Would be its nice go through. And then it's going to creep along the y-axis. Not the y-axis. Y equals negative 2. Go through that point, 0, 2, and then grow rapidly. Okay, don't write this down. You don't have to write this down. What we were graphing were these exponential graphs. And the first one we did was y equals e to the x. And it came through here at 0, 1. And then from there, it started to grow rapidly. Now, I think we've seen this graph quite a lot lately. And if the news reporter was sane, was quasi-intelligent, they would have alerted you that it can't continue in this growth pattern of exponential growth forever. That is just a momentary, temporary model. You can't grow. You can't double the amount of people getting COVID-19 every 3 days, every 2 days, every 4 days, depending upon where it is, or worldwide, whatever it is. It can't keep up that pace. So many people have already died due to it. However, so many people have already recovered. There will be a significant amount of people that don't get it. That is not true. We are looking to get 100% of the world population inoculated. I'm going to put a couple of enrichment videos out, and this word inoculated can mean two things. It can mean infected, and that's when you get it unwillingly. It can also mean vaccinated. That means you actually willingly go ahead and get a minor version of the virus. So, what we're looking for is more vaccinated people than infected people. But eventually, it should reach 100% of the world population is either infected or vaccinated. Our fear is that there's going to be a second wave. And with the Spanish flu of 1918, the second wave was really dangerous. However, those that got the Spanish flu during the first wave did very well. They were inoculated and they survived. So all this shelter in place is trying to do is slow this growth and pan it out until eventually we find not a cure, there is no cure, until we find a vaccine. Once we do that, once people get the vaccine, once people are inoculated, this might be the curve of people dying. And once they get vaccinated, it's going to change from exponential growth to something else. It's going to flatten out. Once it flattens out, that's good. But what's better if it turns into exponential decay. And you'll see this, what looks like the bell-shaped curve. This is also a quasi-fallacy. All they're doing is stitching together this graph with this graph with this graph. And when you stitch them together over time, it looks like this bell-shaped curve. And they want to flatten the curve. So they're trying to get this peak to slow down. That way they can get the vaccines, the hospital rooms available, whatnot, and so forth.